Okay, so trying to factorize this expression is going to be quite a bit more of a challenge. It's also not actually going to be necessary for you to be able to factorize expressions of this level of difficulty. So if you want to, you can skip right over this example. However, if you're willing to try and get your head around it, understanding how to factorize expressions where you've got something on the front of the x squared as well, certainly something as big as that. If you want to try and get your head around that, it will make it a lot easier to understand really well what you're doing in general for this process of factorizing into double brackets. So if you do get something like this, as usual, first step is to see are there any common factors to take out, and as we go through looking at those terms, we can see that there isn't. So we'll move straight on to trying to put this into double brackets. And the process that we used in the last couple of examples is the same here. We still want to try and think in reverse and imagine that we had the two brackets originally and think what we would have needed in those two brackets in order that when we multiply them out, we get back to the expression that we've got here. The only difference with an expression that's as complicated as this one is there's more to think about, so we just need to be more careful with how we approach it. To start off with then, unlike our previous examples, we aren't just going to have an x in the front of each of those brackets because we don't want to make x squared anymore. We want to make 12x squared. So we need to have two expressions, two terms in x that have coefficients on the front, numbers on the front, that multiply together to make 12. So let's have a look at our factors of 12. Let's get them written down over here. We've got 1 and 12. We've got 2 and 6, and we have 3 and 4. So one of those pairs is going to be able to go in here. So it'll be, say, x and 12x, or 2x and 6x, or 3x and 4x is what we're going to have from this. But we can't put it in just yet because it's going to have an impact on what else happens in this bracket, which we'll see in just a moment. Looking at the other end of the expression, that number at the end, just as we've done here, obviously we need to look for our factors of 6 because it's going to be a factor pair of 6 that goes in the end of each bracket to multiply back out when we expand these brackets to make our 6 again. So on this side, let's write down our factors of 6. So that's 1 and 6, and that's 2 and 3. So that was a little bit more straightforward. But again, we can't put those numbers in just yet. And the reason for that is because of the number in front of the x here, which is a 1. Let's just pop that in just so we're clear on that. So let's just pop that in so we're clear on that. We want to make that 1. And that 1 is going to come from multiplying one of the terms in x by one of the numbers, and then the other term in x by the other number, and then adding those two bits together. So we're going to rely on a combination of all of these numbers to make that 1. So I have to come back to that in just a second. Let's have a look at what we've done with our clues so far. So we've sorted out the 12, we've sorted out the 6. We can also use this minus sign now and realize the minus sign in front of the 6 tells us that we have to have a plus and a minus in these brackets, two different signs, so that when they multiply together we get a negative number. So that's that clue there. That's also this other minus, remember, because that just tells us that at least one of the signs has to be negative, and we can see that we've got one of both, so that's fine. So the final step, this is now the tricky bit. We've laid out the rest of our clues. What we now need to do is figure out how we're going to get that 1. And it'll come from multiplying picking one of the pairs here and one of the pairs here, and multiplying one of the numbers in the first pair by one of the numbers in the second pair, and then the other number in the first pair by the other remaining number in the second pair. And because the plus and minus means we're looking for a difference, it's then going to be the difference of those two products that needs to give us 1. So starting out just, let's just pick the first two pairs in each of these lists, just so we can see what I mean by that. So we've got 1 and 12, and we've got 1 and 6. So we might go, for instance, 1 times 1. So that's taking the first one from here and the first one from there, which of course gives us 1. And then the 12 that's remaining multiplied by the 6 that's remaining in that pair, and that's going to give us 72. the difference between wait till those cars go past. The difference between 1 and 72 is obviously not 1, it's 71, so that's not going to do us any good. So it's not that pairing. We can still try another combination with this pair though. We could swap them around. So rather than doing the 1 times the 1, we could do 1 multiplied by 6, which will give us 6. And we could do then the 12 multiplied by the other 1, which will give us 12. But still, that's not a difference of 1 between those two final numbers. So that's no good for us. And we can continue in this fashion. So we've now tried both ways around with those two pairs. We could then try the 1 and the 12 with this pair here, the 2 and the 3. So let's go 1 times 2, for instance, which is 2. And then 12 times 3, which is 36, which still doesn't work for us. So then maybe 1 multiplied by 3, so that 1 here, multiplied by that 3 over there, which is 3. And then that'll leave us 12 multiplied by 2, which is 24, so a difference of 21, so that still doesn't work. So basically you just proceed through all of these possibilities. After a while you sort of get an idea for what you're looking for. Because we want quite a small difference between the two of those, it's very close to 0, that difference of 1. Trying numbers that are reasonably close together is often a good idea. So let's skip ahead and have a look at these pairs, the 3 and the 4 with the 2 and 3. So let's try 3 times 2, so that 3 multiplied by that 2, which will give us 6, and then 4 times 3 will give us 12, that's a difference of 6, so that's no good. But then trying it the other way around, 3 multiplied by 3 will be 9, and 4 multiplied by 2 will be 8, and there we have our difference of 1. So that's what we want to use down here. It's going to be this pair, the 3 and the 4, and it's going to be this pair, the 2 and the 3. We're almost there now. We found everything that we need. We just need to try and assemble it in the right way. So let's look at what's going on here. We want to have a 3 from the coefficients on x multiplied by the 3 from the numbers at the end of the bracket. So that means we'll have a 3x in here, and that 3x, when we multiply it by a number, is going to multiply by the number on the far side of the other bracket. So that's where the 3 has to go. So we get 3x multiplied by 3 to make our 9x in a moment. That leaves us then, it's got to be the 4x in this bracket, which will multiply by the 2 that's put in the other bracket, so that we get 4x multiplied by 2 to give us the 8x that we're looking for. And finally then, we just need to put in the plus and minus. We want to make minus 1 in total. So the way we're going to do that with 9 and 8 is if the 9 is the negative number. So we'll need to have in here 3x multiplied by minus 3 to make negative 9, and then it'll be positive 2 multiplied by the positive 4x will give us positive 8. That's our answer then. Let's just take a moment to expand that out and confirm that it does work, see exactly what we're doing here. 3x multiplied by 4x will be 12x squared, which is what we wanted. Then 3x multiplied by the minus 3 will be minus 9x. Then we've got the 2 multiplied by the 4x to give us plus 8x, and then the 2 multiplied by the minus 3 to give us minus 6. And if we just collect those terms together, we've got 12x squared minus x minus 6 as we wanted. Okay? So quite a complicated example, that one. And like I say, you're not really actually going to need to do factorising of quadratic expressions of that level of difficulty. But if you can see what's going on here in terms of just writing down clues, bits of information that we get by looking at the structure of this quadratic, that same approach applies to the simpler ones as well, and that allows you to solve them quite easily.